Welcome to our video module on airflow. When dealing with cleanroom design, this is one of the most unique and important aspects of a successful cleanroom project. So if you recall when we talked about cleanrooms, we said there were two approaches to getting really clean air. First is to minimize particulates. And this is from nature and also from people in the cleanroom through gowning, etc. The second one was to purge the particulates or to move them through, because no matter what, there will be particulates. We need to find a way to get them out of the space as quickly as possible. This is the focus of controlling airflow in clean rooms. To give you an idea of how much we're purging the air, let me introduce you to the term we use, and that's air changes per hour. Now in general office space, you're looking at something, a handful of air changes per hour, certainly less than 10. In a clean room, we're looking at 1 to 2 or more air changes per minute. So we're really cycling through that air very aggressively. And now a really quick word on how HVAC or heating, ventilation, and air conditioning systems work. They basically pump air through an area. So we're going to look down here at the clean room, and on the roof you might have an air handling unit, AHU. This makes the air good, cools it, heats it, whatever. It sends the conditioned air into the space through supply air. We'll call this supply air. Up above, you'll see me use SA. The air then moves through the space and changes in some way. Maybe it gets dirtier, maybe it gets cooler, maybe it heats up, whatever. This air then returns to the air handling unit to get heated or cooled or whatever has to happen. So in red, we see the return air, often designated by RA, which is what we did here. The supply air and return air can be in all sorts of different places, but the system looks like this. Your teammate who's studying HVAC will know a little bit more about the details of this system. Now, what does this mean? This means like on the class 1000 clean rooms and dirtier, we need something like 25 to 50% ceiling coverage of supply air. So down here, you can see that I have 2 supply air filters and there's a total of 6. So we're looking at something like 33%. That means this clean room right here has enough air changes for class 1000. The second aspect to that is the return air. The grids can be in the ceiling. In other words, right here, this is acceptable. You have it coming down from above and then it returns from above. So if we look at our elevations right here, we have our supply air here. We have our return air here. And that means that when we talk about our air changes, we're thinking of the overall space. So you might have some supply air that comes down this way, and then the same air is going back up through the return air. However, drastic changes are necessary when we move to class 100 and below, and cleaner. The reason is this. Let's go back to our elevation here where we have some supply air coming in. Well, that air, especially at the top, could quickly go over to the return air. We actually call this short circuiting. So while the overall air changes per hour occur, the majority of it is happening up here. Well, if our workspace is down here, it may not get the type of purging required. Or even worse, what's happening to the air down here? There's no way for new air to get in and purge. And so you end up with these little eddies where the air down here can get really dirty, or the air underneath the bench can get really dirty. As a result, in class 100 and cleaner, we introduced a term called unidirectional air or unidirectional flow. This is not unlike laminar flow in your fluids. It's different, but it's not unlike that, where what we expect in a unidirectional flow is that supply air moves from a source to a location, straight lines as much as possible. All right, so what does this mean? This means that your supply air coverage on your ceiling needs to be 100%. In other words, down here, When I have lights and return air and blank space on the ceiling, that's unacceptable for class 100. Here you would need supply air filters on your entire ceiling. In a similar way, if we come over here, you can imagine if the air is all coming down from the ceiling, well, how's it getting out of the room? So here, generally, we have return air sidewall ducts here, and maybe we also have them over here. So overall, the air comes down and across. Or in some of the neat clean rooms, you actually have the floor is perforated, it's open, and the air comes down into the floor and it goes into a return air duct back to the air handling unit. So in that way, it goes truly from the top to the bottom. Now, what's another consequence? Another consequence is we minimize equipment. So the stool, can't use it. And in addition, this desk is going to cause problem. It's going to cause eddies down here. So one solution is to get rid of the desk. No matter what, we want to minimize the workspace. Another solution is what we call perforated desks, where they're these desks that kind of look like screens with all these holes in them. So it allows adequate airflow to go through to ensure that the air coming down in this area is purging the location, that specific location. And a reminder, the goal here is that in the class 1000 and dirtier, you're looking at air changes per minute in the entire space, and that's adequate. But when you're looking at class 100, it's not just air changes per minute in the entire space. You need to make sure that the purging air is going everywhere where there's contaminants. Most importantly, you need to prioritize your clean space. So if you're working on a bench, you want that clean air to be flowing smoothly across that bench first. Well, what do I mean by first? I mean that if you have, let's say, some shelf right here, and even though things can flow through it, it's perforated, let's say it has a bunch of particulates on it, that means everything downstream will get those particulates. And of course, the primary source of particulates isn't some shelf, it's a person. So that means that the air is cleaner up above, dirtier downstream or down below, which really is no big deal when the air is coming from above. But one of the really neat solutions that the semiconductor industry often uses is the supply air will come in from the wall. So that can be used as well. So basically what happens is one wall is all air handling units sending in air, and then the other wall is return. This receives all the air, which means that if a person is in the middle, let's say they're working, this area right here is dirty. Let's try a different color. And the space in front of them, all right, that color is not working either. Here, let's try this. And the space in front of them, this space is clean. I should make one further note about the minimizing the equipment regarding lighting. You can imagine a light that looks like this and all the problems that could happen with not getting good airflow below it. So we don't use lights like that. Instead, we use something like teardrop lights that look a little bit like this. They're like these pendant lights that hang down from the ceiling and air flows nicely around them. The downside is they are point sources of light. So in summary, airflow within a clean room purges particulates very aggressively. We have huge airflow, 1 to 2 air changes per minute within a room. And for class 1000, 10,000, 100,000, this doesn't cause too many concerns. We try and make sure the overall space is purged. However, once we move into class 100 and cleaner, we've become much more concerned not about the overall space, but about all the specific spaces in the room. This demands unidirectional flow as much as possible. In order to meet that, the supply air will generally occupy one entire surface. The air flows all the way through the room. We minimize the equipment and we prioritize the spaces that truly need to be clean. I hope this gives you a basic feel of how airflow needs to be controlled in a clean room and how instrumental it is in clean room design. I look forward to seeing the designs that you come up with in your groups. Thank you.